Okay, so we're going to review factoring polynomials. And this is a graphic organizer that I hope will be a help to you in trying to figure out how to factor the problems that you encounter. So I gave you a review last week. And on that review, there were step-by-step instructions on how to determine what type of polynomial you're looking at and how you would factor it. This is something else that you could use, this graphic organizer. We're going to go through it in a minute. And then on the third page, there's simplified steps on how to identify what type of polynomial you're factoring. So let's look at this. Okay, notice at the very top, it says look for a GCF. That is the first thing that you want to do. And on the pre-test I gave you, there was one that's all you could do was factor out a GCF. And so, and then everything else was prime. So let's go ahead and look at this. If you have two terms, you are most likely dealing with the difference of two squares. What that means is that your first and second terms are perfect squares. And you can factor them out as the difference of those two squares. So what is the square root of x squared? And the square root of 64? Right. So you would have x plus 8 and x minus 8. Okay. Now look at this one. Our first and second terms are not perfect squares. But what is the first thing we should do?
Divide. Find the GCF.
Yeah, find the GCF and then divide by that GCF. So you already said that the coefficient, the GCF of the coefficient is 2.
The variable is in.
Is n. So we're going to divide both of these by 2n. Now, one thing that everyone, or not everyone, but many of you are forgetting is that whatever that GCF is, it has to go on the outside of the parentheses. Do not forget that, otherwise it is partially wrong. So I now have 2n times 9m squared minus n squared. Okay. So now that we factored out the GCF, can we continue factoring?
Yes.
Yes, you can, because it is it is two squares. We have a square root of 9m squared is 3m and the square root of n squared is n. Okay, so I'm just going to write this up here. 9m squared is 3m and n squared is n. So you would write this as 2n, don't forget that. Then you have 3m plus n and 3m minus n. So both of these are the difference of two squares, except for the second one, you had to factor out the GCF first. Okay. So that's when you're dealing with two terms. Now, when you have two terms, will it always be the difference of two squares?
Yes.
No, it won't. Sometimes all you're going to do is factor out the GCF and then you're finished. It was like on our pre-test. This one right here. Notice here, all we could do is factor out the GCF. We couldn't do anything else after that. Okay. All right. Now, the next set is if you have three terms. The first one is a regular trinomial where your coefficient is 1 here, and over here is when your coefficient is greater than 1. Okay. So let's look at this one first. It says find factors of C that add up to B. Do you know where they're getting those terms? C, B, and C. Yeah, from the equation up here. Factors of C that add up to B. Okay. So in looking at this, we need to find factors of -42 that add up to -1. So what are those two factors?
7,
Yep, 6 and 7.
1 and 6.
And which one needs to be negative?
7.
7. So this one's simple, right? X plus 6, X minus 7. There you have it. Okay, now when I look at this second one, I see that A is greater than 2, but what should we try to do first before we factor this? First step always.
Oh, the 50 times 2.
The GCF. Okay, so what is the GCF of this trinomial? 2. So let's factor out the 2. So we have 2w squared plus 10w plus 25. Now we have an A that is 1. So we follow the rules. We find factors of C that add up to B. What are our factors of 25 that add up to 10? 5 and 5. So it's 2 times w plus 5 times w plus 5, or w plus 5 squared. Okay. All right, any questions? Okay, let's go to the next one. Trinomials where A is greater than 1. They call this slip and slide. I want you to cross this out, and I just want you to write grouping. I'm not sure why they say slip and slide. Something else I don't know about. Okay, so remember, you find factors of A and C that add up.
Wait,
Yes,
on the last one, when it was the 2w plus 5, can I just put w plus 5 squared?
yes. 2 times w plus 5 squared. Yeah. All right, so we're going to find factors of A and C that add up to a negative 27. So first, we're going to multiply 30 times 6, and we get 180. Now I have to find factors of 180 that add up to negative 27. Yes.
Yeah.
Oh,
Yes.
yes, you can. Let's do that. Divide by the GCF of 3 first. I forgot to look at that. So we have 10x squared minus 9x plus 2. So instead, we take 10 times 2, which is 20, factors of 20 that equal a negative 9.
10 and 2. Wait. 10 and 1.
3. How about you do 3 there and no, and x plus 10.
Okay.
10 times 1.
There you go. So remember, your negative 4 and your negative 5 are going to replace the negative 9. So we still have 3 on the outside. We have 10x squared minus 4x minus 5x plus 2. And we're going to group these.
So are we not, so
We're going to solve it, yes. But we're solving by grouping because A is greater than 1. So now I still have to have this 3. So I'm going to put 3 out here in parentheses, and now I have to factor each binomial. So the greatest common factor here is 2x. The greatest common factor here is negative 1. Okay. Okay, I see some confused facial
You
expressions.
just wrote it up and then I wrote.
Oh, okay, that's fine. Yes,
Are we doing?
yes. Okay, we're gonna write our final answer here. 3 times 2x minus 1 times 5x minus 2.
Wait.
We factored it out at the very beginning. You can't forget about that 3. It's part of the factored out answer. Okay. Any questions about this one right here? Okay, let's go up to the last one. This is just another form of grouping when you have 4 terms. So this one is actually easier than the one we just did. We have 4 terms, so all we're going to do is we're going to group them like this. Okay. And we're going to factor out the greatest common factor. What is the greatest common factor in the first set? A squared. So we end up with 2a minus b. What's the greatest common factor in the second one? 5. And we end up with 2a minus b. So then our final answer would be a plus 5 and 2a. Oh, a squared plus 5. Yes, you're right. And that is it. Okay. So just a short review of what we have been doing. Let's go to the next page. This is all practice. We may or may not get to the 3rd page. Let's see about it. Okay. So in these first 6 problems, all you are doing is factoring out the greatest common factor. It tells you what to do up here. We will eventually get to a part where you don't know if that's all that you have to do or not. Okay, Dylan.
So is this gonna take like all class?
Yes.
So we just have an extension on the other side?
Yes.
Okay. So what I want you to do is I want you to work on these first 6, ask questions if you have any questions, and then we're going to check the first 6 together. If you're waiting for others to finish up this section, keep going. Okay, because then you'll get if you finish early, you'll be able to work on some of your homework. Okay, so these are the answers for the first 6 problems for the greatest common factor. So go ahead and check your problems and pause the video if you need to, because we're going to move on to the next section. Okay, so for the next 4 problems, they're under the title difference of squares. If you forget what that looks like, look at page 1, which was similar to this right here, where we did the difference of squares right here. Okay, because that's what this is, that's what all these are going to be about. Now, eventually your goal is to get to where it's not titled for you and you can look at the polynomial and tell what you need to do. So if this is a square, if this is a perfect square and this is a perfect square, then you know it's the difference of 2 squares. But then you look at 9 and 10. 9 and 10, you're going to have to factor out the greatest common factor first, and then find the difference of 2 squares. You want to see the answers? Yeah. Okay. All right. So right now I want everyone working on 7 through 10. Okay, here are the answers for 7 through 10. Go ahead and check those. And if you have any questions, let me know. Raise your hand if you have any questions at all about this section. Okay, so we've done 2. We've just factored out the GCF. We've done the difference of 2 squares, or the difference of squares. And now we're just going to do basic trinomial. And I believe this one has 6 problems, 4 on the front, 2 on the back. And if you go to the front, where our graphic organizer is, it's this basic trinomial here where you find factors of C that add up to B. So you could use this right here as an example. Okay. So go ahead and work on 11 through 16. And if you have any questions, let me know. Okay, here are the answers for 11 through 14. Check them. Make sure that you write these down, and if you're not getting them, maybe go back and look at them and see what you did wrong and how you can get it right, because I'll probably be using some of these for your test. Okay. Any questions on this page?
Cause I did it wrong.
Okay.
And you don't have to like this. I know you have to put like the X in 14. Because like there's X and
Yes. Oh, okay, good catch. This one, I should have factored X out first because there's too many X's. So I should have factored out the greatest common factor of X first. So there should be an X on the outside. Good catch. All right, there we go. Corrected. Number 14 is corrected. Okay, I'm going to flip it over to 15 and 16. I haven't done it yet, but I'm going to do it while I have it here. And I'm going to factor out the greatest common factor of 3x on 15. So we have 3x times x squared minus 3x minus 10. So now I'm going to find factors of -10 that give me 3 and -3. So I have it right there. So my final answer does that look right? Number 16, I'm going to factor out a 4 only. A squared plus a minus 20. So factors of -20 that equal a +1 would be -4 and 5. So a minus 4. Do not forget the greatest common factor on the outside. All right. Questions? Okay, this slip and slide right here should be grouping. Maybe I will. Okay, so remember, if you don't remember how to do this, look on our graphic organizer where it says this should be grouping. Trinomials where a is greater than 1. And this is an example right here of how to do that. So this is what you're going to do on problem 17 through 20. So that's what we should be working on right now. I'm going to show the first two, 17 and 18, for these two problems. And I want you to check to see if you got them right. And I know some people are still working on 19 and 20. Before I go to a little maybe hint for those two, are there any questions on 17 or 18? Okay, for 19 and 20, you are going to have to factor out the greatest common factor before you factor by grouping. Okay, so I'll give you a couple more minutes to work on those two. Okay, here are the solutions for 19 and 20. Check your work. For 19 and 20. Are there any questions? This is probably as difficult as they should get, these two right here. because when we move down to 21 through 24, we're actually skipping skipping a step right here. So we go straight into the grouping rather than finding the common factors and all that. So if you need help on 21 through 24, look at your graphic organizer under grouping, and it shows you how to do this. Okay. All right. So go ahead and do those last four. Okay, here are the answers to the last four problems. So check those, please. And then we're gonna go to the third sheet and we're gonna look at that in just a second.
What I thought we weren't doing the third sheet.
We are gonna do some of it because we have time. But there's no additional homework today. I have to change. cameras. Okay,
Well, I thought,
hold on. I'll go over it in just a minute. Are there any questions about this? Make sure if you didn't get to it, that you write the answer down and you can try to figure it out later.
since
You
it's
can just write the answer down.
Okay, so let's go to the third page. The third page is another set of practice problems that now are all mixed up. They're not grouped by just pull out the GCF or find the difference of squares or trinomial with a greater than one or less than one or by grouping. They are not telling you what you're going to do to factor these out. You have to figure it out. So I really like this because up here they give you some simple steps. Number one, always, is there a GCF that you can pull out of the problem? You always want to check for that first. Number two, you're going to have to factor. After you pull out that GCF, if there is any, you're going to factor. You're either going to factor by a difference of squares. They show you what it looks like. A basic trinomial, they show you what it looks like. Instead of slip and slide trinomial, I want you to cross off that slip and slide. And I want you to put A is greater than 1 trinomial. Or is it 4 terms where you're going to just go straight into grouping? So you have to look at that and identify what you're going to factor it by. Then, once you factor it, can you factor again? So check your work to see if you can factor again. So let's go. We're going to start this today. We will finish it on Thursday. And instead of giving you that exit ticket today for a makeup quiz grade, I will give it to you on Thursday, because then that way we have gone through everything that you need to go through to try to understand factoring better. Hold on. Give me 1 minute, okay? So I want you to look at problem number 1. What is the first thing we need to do? Always. GCF.
good job, Dylan.
Factor out the GCF. So I want everybody to do that with number 1 right now. Factor out your GCF. Okay, so the greatest common factor is 7b. Okay, so I'm going to factor that out. 7b times 4a squared minus 9b. Okay, so we did step 1.
No, you get rid of the-
Oh, you're right. 9. Okay, I want you to look at step 2 now. We have to identify if we can continue to factor out based on any one of these 4 ways of factoring.
Yes.
Okay, what do you think?
Um,
Which one up here?
Or the difference of squares.
Difference of squares. 4a squared is a perfect square. 9 is a perfect square. So
Is our test gonna be similar to this?
yes. So it's going to be 2a plus 3 and 2a minus 3. All right. Step 3, can we factor any further? No. All right. Let's move on to number 2. I want to give you the opportunity to figure out how you're going to factor that, go through steps at the top of the page, and then we'll go over it together. Okay, so we have to factor out the GCF, which is 3. So you end up with 3 times m squared plus 3m minus 10. Oh, this looks familiar, actually. Now we have to find, so that's what we did. We did step 1, we factored out the GCF. And in looking at these 4 options, it's a basic trinomial. Basic because there's a 1 right here. So I'm going to find factors of -10 that add up to 3. And it would be a -2 and 5. So 3 times m minus 2 m plus 5. And I can't factor any further, so that is my final answer. Okay. All right, I want you to keep working on this. And you're going to try to get at least, actually the cleanup bell's about to ring. So we will finish this on Thursday. There is no additional homework today. You can continue to work on the book work if you'd like. Okay.
Are you ready to do 7.9?